The graph on the slide is also shown in Figure 9.1 on page 253 in your book and illustrates how the shape of the t-distributions differ from the normal z-score distribution and shows distributions of the t-statistic for different values of degrees of freedom compared to a normal z-score distribution. Like the normal distribution, t-distributions are bell-shaped and symmetrical and have a mean of 0. However, t-distributions have more variability, indicated by the flatter and more spread out shape. For t-tests, degrees of freedom are computed by subtracting 1 from the number of scores in the sample, or n. You can see that there is a relation between the degrees of freedom values on the graph, which is related to sample size, and the shape of the distribution. The exact shape of a t-distribution changes with degrees of freedom. In fact, statisticians speak of a family of t-distributions. That is, there's a different sampling distribution of t, a distribution of all possible sample t values for each possible number of degrees of freedom. As degrees of freedom gets very large, the t-distribution gets closer in shape to a normal z-score distribution. Because t-distributions tend to be smaller than a population distribution, we talk in terms of families of critical t-values that have been specifically calculated for different sample sizes. A portion of the t-distribution table is shown on the slide and is from Table 9.1 on page 254 of your text. The numbers in the table are the values of t that separate the tail from the main body of the distribution. Proportions for 1 or 2 tails are listed at the top of the table, and degrees of freedom values for t are listed in the first column. Just as we use the z-score table to locate proportions associated with z-scores, we will use a t-table to find proportions for t-statistics. The complete t-distribution table is presented in Appendix B on page 575. The 2 rows at the top of the table show proportions of the t-distribution contained in either 1 or 2 tails, depending on which row is used. The first column of the table lists degrees of freedom for the t-statistic. Finally, the numbers in the body of the table are the t-values that mark the boundary between the tails and the rest of the t-distribution. So to use the t-table, you have to know the sample size, or n, so you can compute degrees of freedom, which is n minus 1, whether you are doing a 1 or 2 tail test, and your alpha level. A close inspection of the t-distribution table in Appendix B will demonstrate a point we made earlier. As the value for degrees of freedom increases, the t-column, the t-distribution, becomes more similar to a normal distribution. As you read down the column, you should find that the critical t-values become smaller and smaller, ultimately reaching plus or minus 1.96. You should recognize plus or minus 1.96 as the score values that separate the extreme 5% in a normal distribution. Thus, as degrees of freedom increases, the proportions in a t-distribution become more like the proportions in a normal distribution. When the sample size and degrees of freedom is sufficiently large, the difference between a t-distribution and the normal distribution becomes negligible.